Hello everybody, this is Professor Lombardo, and today I'm recording some extra videos to help you with the product and the quotient rule for differentiation. So up first here we have our product rule. So remember, we think about this as taking our first function times the derivative of the second, then we add, switching the roles, so our second function times the derivative of the first. In this particular case, because of the nice symmetry of the product rule, it doesn't matter which you assign to be your first or your second function. It's always just one function times the other's derivative, and then you switch the roles and add those two pieces together. The chain rule, on the other hand, it does matter very much which function you start with. So in the chain rule, we have a denominator function and a numerator function. We always start with the low, and then the derivative of the high, minus high, derivative of the low, and then we divide that whole difference by the low squared. It's important that you start with the low first because since we're subtracting here, order does in fact matter. Okay? All right, so let's go through a few more complicated examples of the product and the quotient rule. So in this example here, we're dealing with a product, but not just of two functions. Actually, we're dealing with a product of three functions. So you'll notice with our original product rule, it only tells us how to take the derivative of a product of two functions. So here's how we approach this. The idea is to group two of the functions together and treat them as a single unit. All right, so let's take x squared times e to the x, and we'll think of this as one function, our f of x, and this is times sine of x, or g of x. So since now we're technically dealing with a product of two functions, f and g, we can use our original product rule formula. So this would look like our first function, x squared e to the x, times the derivative of our second. So this will be the derivative of sine of x, to which we add, now we just switch the roles. So our second function, not differentiated, times the derivative of our first. So this will be the derivative of x squared times e to the x. Okay? Now, in order to continue, remember we're not done with the problem until we've completed all of the smaller derivatives. So we need to differentiate sine of x. This will be straightforward. But when we go to differentiate x squared times e to the x, we have to use the product rule again. Okay, so in the next line, I'm just going to copy over what we have, and I'm going to solve our first derivative. So we remember the derivative of sine of x is just cosine of x. So here's our first term. To this, we're going to add sine of x. And now I'm going to open up a big set of parentheses because inside of here we have to apply the product rule again. Notice we once again have a product, x squared times e to the x. So now my first function I'm going to treat as x squared. My second function I'm going to treat as e to the x. So applying the product rule again on this product, x squared times e to the x, I have my first function times the derivative of my second plus my second function times the derivative of my first. Okay? So again, we've almost removed all of our derivatives, but since we had to apply the product rule a second time, we have two more derivatives we need to finish. Okay, so in our next line, we'll copy over our first term. So this was x squared e to the x times cosine of x plus, now we'll have sine of x, and we're going to open up a nice big parentheses and finish our derivative here. So we'll have an x squared times the derivative of e to the x, which we know is just e to the x. To this, we're going to add e to the x times the derivative of x squared. So applying our power rule, the 2 comes out as our coefficient, and we get x to the 2 minus 1, or first power, so we can just leave this as x. Okay? So if you want to, in this case, you can simplify a little bit. Depending on how you are going to further use this derivative, you may want to expand this out, so you may want to multiply your sign through in each case. You might want to pull out any common factors that you see, so you might notice there's an exponential in each one of our three terms. We could pull that out. There's also a copy of at least one x in each one of our three terms. We could factor that out as well. For now, I'm just going to expand out so that we have a sum of three terms. Right? So distributing our sign through, we would have x squared sine of x e to the x, right? I can write these in any order that I want because we're just working with multiplication here. And I have 2x sine of x e to the x. So this big, long, complicated thing here is our derivative. Okay, so in our next example, I want you to take a look at the way we build this particular function. Notice that we have a quotient, we have x squared in the bottom, and in the top we have a product. So I'm just going to sketch out something quickly to show you how we quote-unquote built this function. So you can think about trying to create the numerator and the denominator, right? So we started with the basic function x and the natural log of x, and we pieced these two things together using multiplication. All right, so this created x times ln of x. All right, in addition to this, we created our polynomial x squared minus 1, and then we put these two pieces together using a division process. So this left us with x times the natural log of x over x squared minus 1. Okay? So the reason that I point this out is if you sketch out the way that you build a function, right? We created the numerator, we created the denominator, and then we divided the two. It gives you, if you follow it backwards, a roadmap for the differentiation rules that you should apply when you're taking the derivative, right? So whatever the last operation you did happens to be, that's the first differentiation rule you're going to apply. So we're going to make a quick note over here. We're going to start with the quotient rule. And then we'll notice that in the last step, we're going to have to find the derivative of our x squared, and we're going to have to apply the product rule because that was the other operation we used in the other leg. So in the next step, we'll have to do the product rule, and we'll have to do our power rule to figure out the derivative for x squared minus 1. Okay? All right. Okay, so keep in mind, our first rule we want to apply is the quotient, and then after that we're going to apply the product rule and the power rule to unwind those inner derivatives. All right, so moving forward, we want to apply our quotient rule, so we need to identify what's our denominator function. In this case, x squared minus 1 is our denominator function. And what is our numerator function? In this case, we'll use as a group x times ln of x, right? Everything that's in the numerator we treat as a single unit function when we first apply our quotient rule. Right, so according to the quotient rule, this should equal our lower function first, so we get x squared minus 1, times the derivative of the numerator function. So we're going to get x times the natural log of x. And we have to take the derivative of this as 1 unit. So you can already see here we're going to have to apply the product rule when we try to simplify that particular term. Right? Now from this, we subtract our upper function, our high function, x times ln of x, times the derivative of the lower function. Right? On the bottom, we use our low function squared. Okay? So to finish this problem, we still have two derivatives we need to take. And you'll notice each one of these derivatives requires either the product or the power rule, right? And this is what we predicted. We work our way backwards. The last thing we did was we divided our two functions, so the first differentiation rule we apply is the quotient rule, right? Now we're at that second layer. We have to unwind the product, so we'll have to do the product rule on x ln of x, and we have to unwind our powers of x to get our derivative of x squared minus 1. Okay? Since the x squared minus 1 is the easiest, I'm going to start with that one, and then we'll think about applying the power rule on our other piece. So we'll have x squared minus 1. We still have, since we're going to come back to this later, the derivative of x times natural log of x, from which we're subtracting x natural log of x times the derivative of x squared minus 1. We can do this term by term. So x squared, when we apply our power rule, becomes 2x. And the derivative of a constant, right, since it's not changing, the rate of change should be 0. So this will be minus 0. All right. We can leave the bottom factored, x minus 1 squared. We don't need to expand this out if we don't want to. And now there's only one differentiation sign left that we need to finish. Here, what's connecting these two functions is a product, so we're going to use our product rule. For our first function, we'll use x. For our second function, we'll use the natural log of x. So this derivative is going to be complicated. We're going to put it inside a big set of parentheses. Okay, so on the top, we have x squared minus 1. And now we're going to have to apply the product rule. So I'm going to open up a nice large set of parentheses, from which I'm subtracting. I'm going to combine this a little bit. 2x minus 0 is just 2x. So 2x times x we can simplify to 2x quantity squared. And then we have times our natural log of x. All right. On the bottom, we still have x squared minus 1 as a quantity squared. Okay, so now we're ready inside this blue set of parentheses to do our product rule. So keep in mind, we take our first function times the derivative of the second. I'm not going to write this out explicitly since we're dealing with basic functions here. So we know the derivative of the natural log looks like 1 over x. This is in our list of memorized functions, derivatives. And then to this, we add our second function, which in this case is the natural log of x, times the derivative of our first function. And we know the derivative of x is just 1, right? This is the line of slope 1, and so its instantaneous rate of change at any point will be 1 as well. Okay? So I'm going to zoom this out a little bit so we can write our final answer. As ugly as it may seem. Here's what our final answer looks like. Not completely simplified, but simplified a little. X squared minus 1. Our blue derivative here simplifies a little bit. X times 1 over x we can just write as 1. And natural log of x times 1 is the natural log of x. Okay, so the first term in our numerator is x squared minus 1 times 1 plus natural log of x, from which we're subtracting 2x squared, natural log of x, and then we divide the whole thing by our lower function, x squared minus 1, as a quantity squared. Okay, so this is our derivative for the original function. Okay, notice that sometimes you're going to have to layer in quotient rule, product rule, power rules, right? You're going to see a mix of these in order to differentiate complicated functions. All right, and so go back to the beginning of this example and look at how I kind of outlined how did I build that function. If you follow that in reverse order, it tells you exactly the order that you need to apply your differentiation rules. So keep that in mind as a guide. Okay, our last example looks like essentially a polynomial divided by an exponential function. But you may be wondering, how do you deal with something like an e to the 2x? Okay, so what I'm going to do, just like we did in the last problem, I'm going to show you a way that we could build this function. And in doing so, I'm going to show you one way that you can create an e to the 2x. Okay, so keep in mind that if you have like bases, then when you multiply the pieces, you add your exponents. So we can think of e to the 2x as really just being the product of e to the x with itself. All right, so when I create my numerator function, or sorry, my denominator function, I'm going to think of it as taking the product of two individual functions. Okay? All right, so let's sketch this out. To create your numerator function, we're essentially just taking products and sums of powers of x, right? So you can think of this as our straightforward creating a polynomial, x cubed minus 3x plus pi. Right? We know how to create these. To create the denominator function, I'm going to take two functions, e to the x and e to the x, and I'm going to piece them together by taking a product. Okay? Now in the last step, I piece together, so this creates e to the 2x, I piece together my numerator and my denominator using a division. So we have x cubed minus 3x plus pi divided by e to the 2x. Okay, so looking at our diagram, the last operation we use as we're building this function is a division. So that means the first differentiation rule we're going to apply, once again, is the quotient rule. Okay? After that, we have a standard polynomial, which we know how to differentiate. We can do this term by term. And we also need to unwind a product. So we know in our second step, we're going to have to use the product rule as well as the power rule to deal with that polynomial. All right? So we have this sketched out. Let's go and execute our plan. All right, so let's get started with the quotient rule. Right? For the quotient rule, we just identify what's the function in the denominator and what is the function in the numerator, and we apply our rule. So remember, it's low d high minus high d low all over low squared. So our lower function here is e to the 2x. D high means we take the derivative of the numerator function. So x cubed minus 3x plus pi, from which we're going to subtract high d low. So our high function is, once again, that polynomial x cubed minus 3x plus pi. And our lower function is the derivative of e to the 2x. Okay? We divide this whole thing by e to the 2x as a quantity squared. All right, so once again, we have low d high minus high d low over low squared. This is our quotient rule. Now we're left with two derivatives that we're going to have to unwind, right? We have our derivative of the polynomial. This will be a straightforward application of our power rule and our sum and difference rule. We also have this derivative of e to the 2x, okay? So remember, the way that we thought of this e to the 2x as a product is e to the x times itself. So in my next step, I'm going to take this blue derivative and I'm going to rewrite e to the 2x as a product. So we'll get e to the 2x. I'm going to open up a big set of parentheses for the derivative of this polynomial. Term by term, we're looking at the derivative of x cubed. This will be 3x squared. The derivative of minus 3x, right? You can think of this chunk as being a line with a slope of -3, so its instantaneous rate of change is going to be -3. And then pi itself is a constant, and the derivative of any constant is 0. So I'm just going to leave that piece out. From which we'll subtract our high function, so x cubed minus 3x plus pi. And here I'm just going to rewrite the derivative and use the trick that we mentioned in the beginning of this problem. We think of e to the 2x as e to the x times e to the x. So our hope is that in our next step we can apply our power rule. All right, on the bottom we still have e to the 2x as a quantity squared. Okay, so let me get some extra space here. All right, so we need to unwind our final derivative. This is going to use the product rule. Right? Our first function is e to the x. Our second function is e to the x. And we'll open up a nice big set of parentheses to contain our answer from there. All right, so we're looking at e to the 2x times 3x squared minus 3, from which we're subtracting x cubed minus 3x plus pi. And now we have a set of open parentheses to contain the product rule, but keep in mind we're dividing this entire thing by e to the 2x quantity squared. All right, so our first function times the derivative of the second, e to the x, times the derivative of e to the x is just e to the x again. So that's our first term in the product rule, right? And since our first and our second functions are the same, we're just going to get the same answer again, right? Our second function, e to the x, times the derivative of the first, while the derivative of your exponential function is e to the x again. So this is what the product rule ends up giving us when we're applying it to e to the 2x. Okay. So in our last step, we can simplify this slightly, right? We know specifically e to the x times e to the x is actually e to the 2x. And we're going to have two copies of them. So we can think of this as 2 times e to the x. Or sorry, 2 times e to the 2x. All right, so in our last step, we could write this as e to the 2x, 3x squared minus 3, minus our polynomial x cubed minus 3x plus pi. Notice this is in parentheses. And then this I simplified to 2 times e to the 2x. On the bottom, we still have our e to the 2x as a quantity squared. All right, so this ends up being our final derivative.